topological sorting. So what do you mean by sorting? Sorting means in ascending order or descending order, given the list of numbers we sort, is it not? So given a graph, how we are going to sort? So we have to sort in terms of the topology of the graph. So graph is given a set of vertices and set of edges. So we have to order the vertices such that the first vertex comes before the second vertex always. The second vertex comes before the third vertex always. Okay. So that is how we have to do topological sorting. So we'll go with one example and I will explain. Okay. So take down this graph. So this graph consists of A, B, C, D, E, F, 6 vertices and 6 edges. So before that, topological sorting has to be done only for DAG, directed acyclic graphs. So directed graph means the graph with arrowed edges. So graph with arrowed edges is a directed graph. Acyclic graph means the graph should not contain any cycle in any part of it. So that is a acyclic. So only for directed acyclic graph I can do topological sorting. So for undirected graphs or cyclic graphs I cannot apply topological sorting procedure. Okay. Now for this example, so start now. So take this example. So for this directed acyclic graph, I am going to find out the topological sort. So first we have to know about the in degree and out degree for a vertex or a node. So in degree means the number of incoming edges for a node, and out degree means the number of outgoing edges. Okay. And for each and every node, now I am going to find out the number of incoming edges. I am going to find out the in degree for a node. Okay. Now tell me what is the in degree for node B? 0. Node B it is 0. For node A it is 0. 0. For node D, 2. The in degree is, see, A and B is incoming, E and F are outgoing. So the in degree for node D is 2. For node E it is 2. For node C it is 1. For node F it is 2. So out of these in degree values, I have to select the node with in degree 0. Okay. So how many nodes are there? So I have 2 nodes with in degree 0. So out of these 2 nodes, I can select arbitrarily, randomly I can select anything, either A or B. So again I may get 2 different solutions. If I select A, I will be getting one topological sorting. If I select B, that will go for another solution. So both the solutions are right now. Okay. So which one I can select now?
B.
So I start with
B.
A. Okay. B. A or B?
B.
Yeah. Tell me one thing.
B.
A. I will start with A. Okay. So A. So once A is selected, remove A from the graph and all its outgoing edges. The out degree as well as the node has to be deleted from the graph. So delete it from the graph. Now again find out the integers. Update the integers. What do you get? For D the integer is 1. For F it is 2 only. For E it is 2 only. For D it is 1 I have found out. For B it is 0. For C 1 only. All the other values are same only. So again the node with integer 0 is
B.
node B. So now I have to again remove B from the graph. I have to put B in my topological sorting order. Okay. So remove B and all its outgoing edges from the graph. Yeah. Now again update the values of in degree at each and every node. Now tell me.
B 0.
For D it is 0. For F it is 2.
E
For E 2.
C 0.
For C 0. So which one I am going to select now? C or D?
C.
So first I am going to select C. So next have to remove D, put it in the topological sorting order and remove D from the graph. So E and F. Either order I can write, either EF or FE. Okay? I am taking FE. So this is the topological sort of the given graph. Okay? So A, B, C, D, F, E. So if you select B first, what will be the topological order? Do that. B, A. Will it be coming in the same order? So this is also right. Okay? Any doubts in this? Start that. Going to see Dijkstra algorithm. So Dijkstra algorithm is also known as single source shortest path algorithm. So as the name indicates, this is going to find out the shortest path from a single source node to any other node in the given graph. Okay? So a graph, so imagine this as each and every node represents some places. So from one place to other place, I am going to find out the shortest distance or shortest path using Dijkstra algorithm. So single source, if in the problem it is specified the source node, you can take that as the source node and you can compute it. If no source node is specified in your problem, we have to assume any one node as source node and we have to proceed with the algorithm. Okay? Now given the algorithm now, so given the graphs, how many nodes are there? A, B, C, D, 5 nodes are there. So I am going to start with, which node I can start with? Any node I can start with. Okay? For example, A, I am going to start with node A. Okay? So node A, I am going to keep the distance as initially node A to node A. I am going to keep the distance as 0. So A to other nodes, I don't know the shortest path. So A to B the shortest path, I don't know the distance, the shortest path also I don't know. So I am going to keep for each and every other node in the graph, I am going to keep the shortest path as infinity. Okay? So I am going to now prepare a table with designating all the nodes in the graph. Okay? Node A, shortest path is now 0. All the other nodes I have designated as infinity. Okay? Now check the first row, which is the minimum value. Which is the minimum value? 0. So 0 I have to select. So write that corresponding node in the left side. So A. So A is the corresponding node in the left side. Okay. Now from node A to check the adjacent nodes of node A, B and C. So this is a directed graph. So I have two arrows from A to B and A to C I have one path. Now I have to find out the shortest path from A to B and A to C. So I am going to use the formula distance of U plus the cost of U to B is less than the distance of B. I am going to use this condition and I am going to update what is U, what is B? U happens to be the source node. B happens to be the destination. So for any from source to node, from one node to another node, I am going to consider the source as U and the destination as B. I am going to see the distance of U means what I have written in red in here, 0 infinity. So that is the distance that, and cost means whatever edge is given, the graph. I know all of this is a weighted graph, so I know the cost of traveling from source to destination. So I have to sum these two, and if that happens to be the distance of B, B is the destination. So what I have to do? I have to update the distance of B as this formula. Okay. Now consider this case. A is the source node here. A to B, apply the formula. Distance of U. What is distance of U? What is distance of A? 0 plus cost of A to B 10 less than distance of B. Distance of B is infinity. 0 plus 10 less than infinity. True? True. So what I have to do? Distance of B now should be 10. Okay? Distance of B is already infinity, so I have to replace it by 10. Okay? Similarly, A to C. 0 plus 5 less than infinity. Yes, so I have to replace C with 5. Okay? Now update the second row. 0 is already selected. This value. The first row, node A is already selected, so it should not touch this value in the second row. Okay? Now B value is updated to 10. Compare it with the previous row. If it is lesser, you have to fill. Okay? 10. Next one is 5. All the other values remain the same. Okay? Now in this row, which is minimum? 5 is minimum. So what is the corresponding node? So select C in the left hand side. Okay. Now go to node C. Go to node C now. Again I have to repeat the procedure. What are the adjacent nodes for node C? C to A. Do you have any arrow? No. C to B. So B is already, A is already done. C is now done. C to B and then C to E. I have two nodes. So C to B, apply the formula. C to E, apply the formula. Update the values. Only if it is lesser than the previous value, I have to update. If it is greater than the previous value, I should leave as it is. Okay. C to B now compute. What is C now? 5. 5 plus 3. 8 less than 10. Yes. So I have to update 10 with 8. Okay. 5 plus what is this value? 5. C to E is 2. 7. E values. So 5 plus 2, 7 less than infinity. Yes. Yes. So I have to update infinity with 7. Now write down the values here. Third row. So I should not touch this one. C is already selected. Don't touch this one. Okay. Now C to B, the value is 8. C to E, the value is 7. This is the same as it is. Okay. Which is the minimum value here? So select E. Let it be here. So now E is done. Okay. So now from E, what are the adjacent nodes for E? D and A. Am I right? A is already done, so don't touch this. So E to D alone. E to D. 7 plus 6. 13 less than infinity. D value, so select D. So D is also done. So almost done in the graph. Okay. Now my table is over. Now what do you infer from the table? So what is the shortest distance from A to B? A to B it is H. From A to C
5.
it is 5. From A to D it is 9. A to E it is 7. So the single source node is A. For that source node A, I found out the shortest distance to all the other nodes in the graph. Okay. Now how to find out the path? I know that the shortest distance from A to E is 7. But what is the path to reach from A to E? How do I go? How to find out from this table? Yes, for that what I have to do is start with this one. Put arrow mark here. So here it is the table E, is it now? So take that E, compare it with the previous value, go to the previous row, whether the values are different, 7 and infinity, both the values are different. So if it is different, then I have to go for this value. Okay, what is the corresponding thing? C. Go to C. Now compare 5 with the previous row. They are different. Yes, so I have to go with the selected value there. That is corresponding to A. Now see, write it in reverse. The path is from A to E is ACE. Right? A to C to E, the distance is 7. This is the shortest path. Understood how to do? Suppose I want to do it for A to D. A to D. How will you find out the path? How will you find out the path? Start from D. Here, last row, is it not? Put arrow mark here. 9. The value is 9 here. Compare it with the previous value. It is different. If it is different means I have to select the box value here. So box corresponds to B. So D, here it is D, next one is B. Compare it with the previous row. 8 and 8 both are same. So don't select it. Go to the previous row. 8 and 10. So select it. The corresponding box is 5 which corresponds to C. So D, B, C. 5 compare it with the previous row. The values are different. So select this. So it will be A. Now check the reverse A, C, B, D. Whether it is right? A, C, B, D. 5, 8, 9. So this is the path for traveling from A to D in the shortest route. Understood? How to find out the shortest distance and the shortest route? Any doubts in this? So you can apply the same algorithm to undirected graphs also. Okay? So don't fear this. The number of nodes may be larger, number of edges may be larger, but with a simple table, a single page you can solve it easily. Just only one formula. Okay? Yes, any doubts? Stop.